Let's ask a simple question. Where are chlorine's electrons? So from the box there, we can see chlorine has 17 protons, so we know it must have 17 electrons. You could draw a Bohr diagram. You put 17 electrons spread over 3 rings. The only issue is that we now unfortunately know that the Bohr model that we came to love is wrong. Right? Ever since it's been shown that hydrogen is not the same as helium, when we pass an electric current through it, we can see that the electronic transitions take place at different energy levels. Right? We see different lines. This is where the Schrödinger model and quantum mechanics comes in. So the Schrödinger model takes the Bohr rings and twists them a little bit. Electrons are now found in what are called orbitals. Each orbital can hold 2 electrons, and these are divided into energy levels similar to the Bohr model. Now, from here on in, you may want to get out a blank periodic table, a paper copy of one, and you may want to write the orbital labels on top of it. So, how does the Schrödinger model fit the periodic table? Well, first we have what's called a 1s orbital. A 1s orbital, as you can see, is a sphere. It can hold 2 electrons. 2s orbital can also hold 2 electrons. That's a little bit larger. It's on the outside of the 1s orbital. After that, the same size as 2s is 2p. There are 3 p orbitals at the second energy level. They can hold a total of 6 electrons. 3s orbital comes next. It can hold 2 electrons. The 3p subshell has 3 orbitals. Each can hold 2 electrons for a total of 6. Then we have the 4s orbital that can hold 2 electrons. Now we're going to move a little faster. The 3d set can hold 10 electrons, followed by 4p, which can hold 6 more electrons. The 5s orbital can hold 2 electrons. The 4d orbitals can hold 10. Move over into the 5p set. 6 more electrons can go there. 6s can hold 2 electrons. 4f, way down there at the bottom, 7 of them can hold 14 electrons. Come back up to 5d, can hold 10 more. The 6p orbitals can hold 6 electrons in total. 7s can hold 2 more. Moving down to the bottom now, 5f can hold 14 more, spread over 7 orbitals. 6d can hold 10, and finally 7p can hold 6 more. Back to my original question. Where are chlorine's electrons? To answer that, let's have a look at an actual periodic table. Let's draw in electrons. So I represent an electron with a half arrow, so an up and a down. First ones, hydrogen and helium, are in the 1s orbital. So I write 1s and a little superscript 2 to say there's 2 electrons in that orbital. Followed by lithium beryllium is 2s2. 2p6 from boron through to neon. 3s2 is sodium magnesium, and then aluminum, silicon, phosphorus, sulfur, and chlorine. 5 more electrons, that's 3p5. I'm going to circle the exponents here. 2 plus 2 plus 6 plus 2 plus 5 equals 17. And what's the atomic number of chlorine? Well, that's the number of protons, 17. That's equal also to the number of electrons in a neutral atom. The exponents in an electron configuration tell you how many electrons are in the atom, and the overall configuration tells you where they are. The exponents need to add up to the same number of electrons present.